Hello friends, I Dr. Minal Harde from Department of Pharmaceutical Chemistry, PE Societies, Modern College of Pharmacy, Nigri, Pune. Welcome you all. Today we are going to see in detail about thermal gravity analysis. So in thermal gravimetric analysis, we are going to cover it in the two parts. First part include definition, introduction, wide variety of applications, then principle and instrumentation. In the second part, factor affecting TG curve and application will be covered. So first of all, what is thermogravimetry? Thermogravimetry is a technique where the weight of substance in an environment heated or cooled at controlled rate is recorded as a function of time or temperature. When a matter is heated, it undergoes certain physical or chemical changes. Physical changes such as melting or boiling may occur at a wide variety of temperature, depend on material involved. Chemical changes such as decomposition or reaction may occur at different temperature. Then thermogravimetric analysis or thermal gravimetry is a method of thermal analysis in which changes in physical and chemical properties is monitored. Then physical changes such as phase transition, vaporization, sublimation, adsorption, desorption can be monitored. And the chemical changes such as dissolution, chemisorption, decomposition, oxidation or reduction is get monitored or studied. Now thermal analysis is widely used in many areas such as polymers, pharma industry, then petrochemical industry, food industry. In the academics also it is used, in the government sector, then aerospace, textile, chemical and other sectors also. So if you will see in many areas, so in thermal analysis is mostly used in many areas in which the largest share is present with the polymer industry. Then different types of thermal techniques are there. These are the few list of thermal analysis techniques. So we are mainly focused on three types of thermogravimetry, and we are concerned with the thermogravimetry here. So here three types of techniques are there in the thermogravimetry. So first is the isothermal or static thermogravimetry, in which the sample weight is recorded as a function of time at constant temperature. Second is the quasi-static thermogravimetry, in which sample is heated at constant weight at a series of increasing temperature. And third is the dynamic thermogravimetry, in which sample is heated in an environment whose temperature is changing in a predetermined manner, generally at predetermined rate. Then thermogravimetry. This is the graph we are obtaining after each study. Here we are seeing A to A dash. This indicates the horizontal plateau, which indicates no weight loss. Then after that, curved portion, that is A dash to B dash, it indicates the weight loss of the sample. Then again horizontal plateau is coming. This indicates how much weight loss is obtained. We can get that final weight loss is presented by B dash to B. This is the thermogravimetry curve. Then what is the principle of thermogravimetry? In this technique, the change in sample weight is measured while the sample is heated at constant rate under constant air pressure or nitrogen atmosphere. This technique is effective for quantitative analysis of thermal reactions that are accompanied by mass change such as evaporation, decomposition, gas absorption or dehydration. Then the thermogravimetric analyzer measures the change in the mass of sample as the sample is heated, cooled or held at constant temperature. Now we are starting with the instrumentation. In instrumentation, many components are there such as recording balance is required, balance controller, sample holder is required, furnace is required, furnace temperature sensor, atmosphere controller and recorder. So all these things are required in the instrumentation. This is the Brief diagram of the thermogravimetric analysis. So starting with the first, instrumentation. In this technique, the change in sample weight is measured while the sample is heated at constant rate. Then first we are starting with the balance. So what should be the ideal properties of balance? Balance should be accurate, sensitive, reproducible, and should have capacity to reproduce the same result. It should have adequate range of automatic weight adjustment. It should have high degree of mechanical and electronic stability. It should give rapid response to weight change. It should be unaffected by vibration. It should be simple to operate and versatile. Then two types of balance is mainly used in the thermogravimetry, such as deflection balance and null point balance. So deflection balance, it is of four types, such as beam type, helical type, cantilever beam, torsional wire. So we will see one by one all this balance in detail. First is the deflection type. In deflection type, first is beam type. In this balance, there occur a conversion of beam deflection about the fulcrum into a suitably identifiable weight change curve by either of the following: photographic recorded trace or recorded signals generated by suitable displacement measuring transducer or electromechanically drawn curves. Second is the helical type. In this balance, elongation or contraction of spring takes place as a result of weight change. Transducers are used for recording the change in length of the spring. Quartz fiber are mostly or widely used to avoid fatigue problem as well as anomalous result with change in temperature. Next is the cantilevered beam type. Here in one end of the beam is fixed and the other end of which the sample is placed is free to undergo deflection. This technique of deflection measurement is same as in beam type balance. Last is the torsional wire type. The beam is attached to a taut wire which acts as a fulcrum. The wire is fixed at one or both ends so that deflection of beam are proportional to weight change and the torsional characteristics of wire. The metallic ribbon is also used instead of taut wire. Detection devices are similar to the beam type. So all these are the four types. Next is another is the null point balance. So null point balance is more commonly used. In this balance, sensor is employed to detect the deviation of beam from its null position. A restoring force of either electrical or mechanical weight loading is applied to the beam to restore its null position from horizontal or vertical null. The restoring force is proportional to the weight change and this force is recorded directly by the transducer. Next is the recording balance. It is the most important component of thermobalance. Commercially available balance can provide quantitative information about 1 mg to 100 g mass. Most common type of balance is ranging from 5 to 20 mg. Next is the sample holder. It is constructed from glass, quartz, alumina, stainless steel, platinum, graphite, etc. Practically four types of sample holders we can use. First is the shallow pan or deep crucible, loosely covered crucible or retro cup. So we will see all these sample holders in detail. First is the shallow pan. It is suitable where it is necessary to eliminate diffusion as the rate cooling state. Example, in case of polymer, side reaction may occur. So in that case, sample is arranged in the thin layer so that as soon as volatile fragment is formed, it is free to escape. Next is the deep crucible. It is used in such cases where side reactions or partial equilibrium is to be desired. It is also used in study of industrial scale calcinations. Then loosely covered crucible. It is suitable when the rate of weight loss and not the exact temperature is taken into consideration, as in case of self-generated atmosphere studies. Next is the retort cup. These are useful in boiling point studies. The retort provides the single plate of reflux essential for simple boiling point determination. Then furnace. The choice of furnace, heating element and type of furnace depend on the temperature range being studied. So here various type of material we can choose according to the temperature requirement. Suppose nichrome wire we are using, so we can achieve a temperature up to the 1100. If we are using the platinum or alloy of platinum or rhodium, so we can achieve the temperature from 1100 to 1500 degrees Celsius. Or if we require the temperature more than 1750, so we can use tungsten or molybdenum as a material. The size of furnace is very important. High mass furnace is much better than low mass furnace because it becomes easier to obtain a large uniform hot zone in the high mass furnace. Purging system. Purging system, here we have to purge or remove the oxygen or the whatever the atmosphere which is present, and we have to pour the inner atmosphere. So it is very important. So generally nitrogen or argon gas we are using for purging the furnace. We can prevent the oxidation of our sample by using the nitrogen or argon gas. In some analysis, purging gas supply is continued during analysis process. Example, sample bituminous cool. The nitrogen was employed during first 18 minutes. The moisture content and the percent volatile are recorded. Then the gas was switched to oxygen for 4 to 5 minutes, and further application of again nitrogen gas is possible. So finally the measurement of ash content we can do with the purging system plays a very major role in it. Then temperature measurement. It is the most common method. Generally the most common is the thermocouple. Thermocouple is used to measure the temperature. Suppose of the sample. Suppose for 1100 degrees Celsius, chromyl or aluminum thermocouple made up of alloy of platinum or rhodium is used. For higher temperature, tungsten and rhenium thermocouple is used. The position of temperature measuring device relatively to sample is very important. Here we are seeing the three positions. So first position is exactly below the sample holder, second is within the holder, and third is in contact with the container. So mostly third contact is, or third position is more preferred one, because we are getting the exact sample temperature by this technique. Then recorder. Two types of recorders are there: time-based potentiometric strip chart recorder and XY recorder. In some instrument, light beam galvanometer, photographic paper recorder, or one recorder with two or more pens are used. One can check the heating rate of furnace for linearity. In XY recorder, we get curves having plot of weight against temperature. Percentage mass change versus time or temperature is suitable mode of recording data for thermogravimetry. So here we have finished the part 1 of the thermogravimetric analysis. In the part 2 we are going to see the various applications as well as factor affecting the thermogravimetry analysis. Thank you so much.